So is this like a dream or something? Because I've seen all of you here. And are you all like repeating numerical methods? What the heck is going on? Like I came in and started seeing your faces. I'm like, sure. Because this is numerical methods. Like either I'm in the wrong class or you are. Oh, there's some new faces here, some old new faces. So what are the odds that we're matched for 2 consecutive semesters? And what are the odds that this is statistics or numerical methods? 50-50? I don't know. What do you think? So, okay, let's think through this a little bit. I'm teaching one course this semester. So the odds of me being wrong are practically zero. If I'm reading my email and I know my like job assignments, right? What about you? How many courses you're taking? 4 courses, right? So you have more odds that you're wrong than I am, right? Because you're more likely, unless you check your schedule. If you check your schedule, which I think some of you were like looking like, is this the right room? Okay, I meant this as an anecdote. This is indeed statistics. And I wanted to think of an example that ties it into statistics. I tied it a little bit to probability. But there is probability in statistics, and I'll talk about that today. Statistics is a very beautiful topic. I've always wanted to learn statistics because I never formally learned it. And last semester when you took numerical methods with me, I told you that you can be a very effective teacher if you are learning the material at a later stage in life because you know how to learn and you know how to ask the right questions. And I've never taught stats before, okay? So I've never taught statistics. This is the first time, and you are my experiment, okay? So there's a lot of benefits of doing that because we can custom tailor the course based on what we want. And based on what I've planned so far, this is gonna be a different, I don't want to use the word monster, you know, like the Loch Ness monster. It's not a monster, you know, but like the Loch Ness animal. This is a different animal than numerical methods, okay? It's easier in many aspects. I don't expect the homework to be as intense as numerical methods like programming and Python and import matplotlib and all that stuff. But this is going to be heavy on analysis and thinking deeply about things and what it means to do an analysis, critique a study, do probability, which is a nightmare. I hate probability. Who loves probability, like thinking on the spot, like what are the odds that, you know, you have an ace of hearts? Oh, okay, except Nicholas there. No, it's a tough subject, right? So, but we're gonna work through it together. Luckily, with statistics, at least in the context of this course, the need for probability is somewhat limited to figuring out what a probability distribution is going to be needed for a statistical analysis. This will become clear as we go along. But first, I want to do the usual. Most of you have seen this repeated. It's going to be repeated from numerical methods. I see a few new faces, so welcome to the class. My name is Professor Tony Saad. You can call me Professor Saad, Professor Tony, Dr. T, Dr. Saad, you know, whichever one of those. Welcome you to this class. It's going to be a fun semester, I hope, and I plan. We'll do some administrative stuff in the beginning just to make sure that's out of the way. You understand the rules of this class and how we're going to plan it. It will be very similar to numerical methods. If you've taken numerical methods with me, it will be new to you, but we'll explain it. So we'll talk about syllabus, some administrative stuff, like your TAs, office hours, help sessions, etc. Perspective and importance of statistics, Python, Excel, R, which one are we going to be using, and a little bit on my teaching philosophy. But first, I'd like you to just grab a pen and paper. I remember all your faces, but maybe half your names, okay? So I'd love to, you know, for you to refresh my memory. So just grab a pen and paper and use a decent sized font, please, to put your name on it so I can see it. Okay, Well, keep those sheets with you. Put them up as we go along. If I call upon your name, I'd love to call you by your name so that by the end of the semester, hopefully, I'll remember your name. But trust me on one thing, I will definitely remember your faces. It's much easier for me, visual memory. Names take some time. It's easier for you to remember one name, right? But for me, I'm going to remember 55 names. So, all right. Syllabus and administrator stuffs. First, let's start with meeting your amazing TAs. This year we have Zach and Ariana. So they're sitting over there. So Zach and Ariana. Ariana is a senior student. She was my TA in numerical methods when Zach was taking numerical methods. She did research in my research group for some time, and she's gonna finish up this semester and looking for great things in the future. Statistics might be in her future, we'll see. Zach is a data scientist, self-declared data scientist, as far as I can tell. So he's gonna be really an asset for you and for me in this course. He's in his junior year right now and gonna be very helpful. So these two guys are gonna run the help sessions for you. They're gonna be your go-to people. They are my boots on the ground. They are your voice. If there's any concerns, any feedback you don't feel directly sharing with me, you can share with them and they will pass it along anonymously. So feel comfortable with them. Please be polite with them. Please be respectful of their time. And they know the rules as well. So sometimes they might tell you, look, go back, think about the problem, and then think about the problem, then come back and ask me the question, ask me a specific question. That's not them being mean, that's me being very decisive in the rules because I want to protect their time and your time. Imagine they have a 1-hour help session. Typically we get 10 students per hour. So, 5 minutes per student, 7 minutes per student. So we don't want anyone to unfairly hog the help session time. So typically they will tell you, like if the process is taking a long time, they'll point you in the right direction. They'll tell you, go study this, think about it, and then come back with a very specific question. Like you cannot come and repeat the lecture for me. What they're gonna tell you, they'll tell you, hey, go back, watch the YouTube if it's available, read the lecture, read the chapter in the textbook, and then come and ask a specific question. What's a specific question? A specific question is like, I don't understand here how that calculation ended up in this number. Okay, let's do it together, figure this out. Okay, versus asking, okay, what is a matrix? Well, you know what, you go do your job first and then come, if you're still having trouble with not understanding a major concept, then that gets escalated to me directly and you come to me and we work together on figuring this out. Okay, so mutual respect between you and the TAs, respect their time, they respect your time as well. We want to be able to help everyone. There will be 4 help sessions, as I will show next. The course will be entire. So, secondly, also, I apologize about this crap here. I don't know what's going on. I love the 2 projectors here. I love this room. But every year, last year we had a problem with one of the projectors, and this year apparently we have another problem. So I apologize for this. I came to class and this was here. So apparently it broke during the break. Hopefully it comes back from Christmas break next week and we can have the 2 nice big projectors so you can enjoy the lectures. There's only one place for you to get information about the course, and that's the Canvas webpage. So make sure you see the Canvas page for the course. I will post everything over there: homework assignments, announcements, quizzes, recordings of lectures, PDF notes, everything. Now, the recordings of the lectures, if they are recorded, I will try to record every lecture, okay? But sometimes things happen and the lecture is not recorded, there's no audio, or like the battery dies and I'm not paying attention, so there's no lecture recorded. Don't rely that there's going to be a lecture on YouTube. Don't rely on that. This is an in-person course. Please try to come and be here in person. I know many of you have jobs and other responsibilities. Try to work it out so that you've invested so much money to come and take this course at this great university. So try to come in person. And again, I'll do my best to keep these. My success rate with YouTube is like 99% recordings, but things can happen, okay? So if you don't come and there's no YouTube lecture, then you'd have missed a lecture. Okay, so for YouTube, please subscribe to my YouTube channel. Now, I'm not going to get new subscribers because most of you are already subscribed. So tell your cousins, your friends, your family members, everyone again, everyone, tell them to subscribe to trigger the algorithm. For the new faces, please go ahead and subscribe. It's called Professor Saad Explains. There's this beautiful logo over here. And I use the, Utah, on the Utah license plate, there's Life Elevated. So I'm going to put Teaching Elevated. So, it's a kind of fun little YouTube channel. Please subscribe to it so that you get alerts and updates, and stay subscribed forever, okay? So you can hear from me for the rest of your life, hopefully. And I've been posting some guitar videos because last year, some of you were trying to dig up my other guitar channel, which is very private and hidden and nobody knows about. So to circumvent that problem, to be defensive, I'm like, okay, let me post some guitar videos on the main channel so that people stop looking for the other channel, which is top secret. So you can enjoy some of the newbie guitar videos there. Okay, so I will post the links to the YouTube videos on the main Canvas website. Sometimes it takes me a day to get that video processed and posted. Sometimes I forget. But if you're subscribed, you'll get an alert that I uploaded a new video. So you can just go straight to YouTube and watch it. Press the like button. If you don't like the video, don't press anything. But if you like the video, press the like button. It also triggers the algorithm, helps with the rankings for the channel. And email. Don't send me an email to my work email that's advertised on the website. Because that work email, like tony.saad@utah.edu, it's not like I don't want you to email me on that email. It's just there's a high chance I'm not going to see it and I'm not going to respond to it. I get over 1,000 emails a day. Now, if you email me on Canvas, I check I'm on Canvas every day. And if I see a message on Canvas, I know that's going to be from you because I only have 55 students. And if I get an alert, there's an email there, I know it's important and it's you, and I'm more likely to answer it usually within an hour, 2 hours. Within 24 hours, definitely you'll get an answer. But if you send it to my work email or my other email, I'll see it. I'm like, oh yeah, I'll respond. And then tomorrow comes and I have like 1,000 other things to do. And then I will forget about it, okay? So use Canvas for course-related communication. If you want something private, if there's something outside the scope of the course, send me a message on Canvas and we can figure out a way to meet and continue the communication. Once you're done with the course, in there you need a recommendation letter, you need something else, then the communication will be through the work email, obviously, but then, it will change, the priority will change for those, okay? All right, let's see what's next. Office hours, Wednesdays from 1 to 2:30. There's no office hours this week, no help sessions this week, just to get things started. We're just barely coming from the break and everyone's brains are scrambled. So we'll take it easy this week. But every Wednesday I'll be in my office 1 to 2:30. My office is it's weird, it's the second floor in the metal engineering building. If you measure the floors from the west side of the building, but if you are like just kind of down here, it will be the ground floor, that building. So it's 2286 right across the Dougal or the ICC lab, what they call it. Most of you know where that is. If not, just find your way around it, please. It's right under the department, the main offices for the department. Come with clear questions. For those of you who don't know this, and I mentioned it a minute ago, again, you don't come to me say, hey, I didn't understand anything. And I'm going to tell you, did you actually study the material? And if you tell me no, I'm going to tell you, go back, study the material, put an effort, because you have to put the effort to learn it. Okay, I cannot learn it for you, or I cannot learn it on your behalf, right? I have a different way of learning. I've already learned the material, right? I cannot learn it for you. And if you don't put an effort to learn it, it's not going to register. So imagine this. It takes me, I'm building this course from scratch, literally. Every slide, every lecture. It's a 1.5 hour lecture. And it takes me about 15 to 20 hours per lecture. Just the commitment to read the material, summarize it, analyze it, come up with questions, put the design and all of that, and iterate over it. So if I'm putting 20 hours and I have 20 years experience in engineering, I expect you to do the same, even more, to study a topic and master the material, right? So put the effort first and then come, and then maybe then it's usually just a little icebreaker, like with one sentence or 5 minutes together, you'll get the eureka, the aha moment that, okay, now I get it finally. But you have to put the effort, okay? You have to put the effort, please. We will have 4 help sessions, Tuesdays from 1 to 2 and 4 to 5, and Thursdays from 1 to 2 and 4 to 5. Why we should probably make a statistical analysis on this based on data from the previous 7 years of numerical methods help sessions. Intuitively and anecdotally, over the years, I figured that these are the best times where we can reach most of the students. We can never reach everyone. We don't have unlimited resources, and neither do you, right? You can't pay for private tutoring, so we're in this kind of mass education system. We do our best to make sure everyone is getting a fair share at learning the knowledge. Now, if none of these hours work for you, then we'll figure out a different mechanism to help you with office hours or individual meetings, right? So even outside the standard office hours, we can meet at any time. Just send an email and say, I need help with this concept or that concept, and then we figure out a time, and you can come and we'll give you the help, okay? But these are the standard help sessions. They're also at the Dougal lab, so right across my office. So I'll be around. I'll usually float around and help Zach and Ariana. So remember those. They're already posted on Canvas as well. Going back, all communications has to go through Canvas. So send me, obviously you can send me a private email or a direct email to my utah.edu or chemeng.utah.edu. The chances of me replying in time is very low, okay? Because there are so many other priorities. If you send it on Canvas, I will 100% respond to you, okay? So keep it on Canvas. Anything course related, keep it on Canvas, please. And copy Ariana and Zach unless it is personal. If you need something directly from me, then just send the message to me. Anything with homework questions, grading questions, etc., copy Zach, Ariana, and me, because now we triple the odds that one of us is going to answer the question. And the way this works, we have a round robin. Like Zach would check the Canvas email twice a day from 10 to 11, and then from 6 to 7, and then Ariana from 2 to 3, and maybe from 9 to 10, right? So if your email falls, after one of those or within one of those, one of us is bound to get to it, okay? And we will answer you, but make sure you copy everyone. And sometimes you forget, you send the message to Zach or Ariana, and then they'll respond copying all of us back so that we are all in the same loop, okay? This year, I will adopt actually a textbook, and it's called, I spent the entire break and like the last month in numerical methods ordering books and like trying to figure out which book I want to adopt. And if you know me, I do not like jargon. I do not like complicating things more than they should be. I like clarity, and I think even the most complex of concepts can be clearly explained without the need of arrogant jargon and fancy, mathematical symbols, etc. This is a great textbook that I think delivers that. It does deliver high quality statistical education, and it does it in a very clear and concise manner. It's called Beginning Statistics. You get whichever edition you can get. The 3rd edition is pretty cool. They have a lot of online resources as well. So this will be my guide, at least for this semester, as I build the repertoire of knowledge for statistics. So you can grab a copy of that, and I don't have a digital copy of it that is good resolution. It's like been impossible to access that, because usually I would share chapter snippets with you within legal fair use. So, you know, not all of you want to go and purchase a textbook, etc., but you can probably find a used one. And if not, you know, I'm condensing most of the material in these lecture slides. Now, I think the textbook will be helpful. It's been helpful to me as I did my reading and kind of learning myself. Homework assignments, again, like numerical methods, there's going to be up to 10 assignments. I frankly don't know how many assignments. I haven't even written the first assignment yet. There might be 15, or there might be 8. There are 10. I'm hoping for 10 assignments. The 2 lowest assignments will be dropped, and therefore there will be no homework extensions. So, you know, you're running late, or like, you know, some event happened, and you couldn't do the homework, then just take one of the drops on the assignment. Okay? Just take that. So no assignments. Now, there might be extenuating circumstances. Could be, you know, something going on. You need to be out for a month. You might miss 4 homeworks, and we'll work something out. Okay? I'm a human. I understand this. Things happen in my life as well. Just talk to me. But standard policy is that, you know, if you miss the homework assignment because there was a snowstorm, you know what? Just drop the assignment, forget about it, and move on. You'll get plenty of chances, like was shown in numerical methods. In the end, we had like 2 extra assignments that counted for 100%. They were like free assignments, essentially, and everybody was just fine. So no homework extensions. You still get a late penalty. I don't know why this is shifted to the left. Let me see if I can adjust this a little bit. Oh, no. That's worse. Okay, and there should be bullet points over here. There's a 25% daily penalty. So let's say you're running late, but you don't want to drop the homework. You know, take the daily penalty, 25%. It's a discount on the homework, and, you know, submit it, and you weigh that. Maybe there's a problem that's 10 points, and you don't have time to finish it, but 10 points is only 10% of the assignment. It's not worth taking the 25% penalty. Just submit the homework without the last problem. You know, do that calculation yourself. Typically, assignments are assigned on Thursdays and due the following Thursday. So every Thursday, expect a homework assignment. Now, this year is going to be interesting. Most of you've taken numerical methods with me. You're used to doing Jupyter notebooks and submitting the Jupyter notebook itself and the PDF, so the source and the PDF. This year for this course is going to be different, because not all the material is going to be programming intensive. There's going to be more analysis, so more discussion, more thought processing. So not all homework assignments are going to be required in Jupyter Notebook. And in fact, I'm going to give you the freedom to choose whatever platform you want to write your homework in. You can do Microsoft Word, Google Docs, or a Jupyter Notebook. But as long as you submit the PDF for it, that's what I ask of you. Now, there will be some assignments where there's going to be coding, and we'll be doing examples in class, obviously. Those, I will tell you, submit this as a Jupyter Notebook. So you submit the notebook source plus the PDF, because we will be grading the PDF, but I need the source as well to look at your code, see if if I need to run it or anything like that. But like for homework 1, for example, I'm going to ask you some questions like, okay, here's a study. Is this a statistic or a parameter? What is the population? You don't need Jupyter. You need Python for that. Okay, you just need your mind and a word processor. Okay, so you type it, and you submit the PDF. Okay, but I will tell you if I need a Jupyter notebook or not. Okay, if you have a CDA form, let me know, and we'll figure things out, how we do the whether exam accommodations or homework accommodations. No solutions will be provided, but we'll discuss some solutions in class together, give plenty of examples in class. Now, assignments, again, I still stand by my policy over the years. I don't give partial credit on assignments, or I say I give limited partial credit on assignments and a ton of partial credit on handwritten exams. But the reason I don't give partial credit or a lot of partial credit on assignments is because the assignment is going to mimic a situation in real life where you have a project to finish, you have some time to finish it, and you better get it right. Last year, someone asked me, what keeps you, I don't know if someone asked it or I said it, what keeps me up at night is having mentored someone in engineering who ended up making a mistake that caused a disaster. That's what keeps me up at night. Teaching the wrong thing or doing something incorrect with the knowledge that I'm trying to convey to you. So homework, one way that I can make sure that you're not going to make a mistake is within a long period of time, you have 7 days to finish a sequence of problems, you got to get them right. If you don't get them right, you're going to lose points. So then you learn, next time, I'm going to do it right. This is not a timed exam, like an hour exam. You have 7 days. Okay, figure this out, get it right. If you don't get it right, you're not going to get credit for it. It's better that you make the mistake here and lose credit here than actually doing that 4 years from now when you're doing real things that are affecting people directly. Okay. Now there is some partial credit I'll explain in a minute. Assignments should be clear, should read like a regular report, and if your assignment is going to be in Jupyter Notebook, it has to have a discussion in it. Once we get to coding and Jupyter Notebooks with statistics, I'll talk about that. But essentially, the policy I had in numerical methods is that a print statement from a code does not count as a discussion. A print statement is the result of a code. You have to think as if we don't see the print statement. We don't see the code. I need to read your interpretation of this code, of this number. Like this will not count, this print statement of the sum. As far as I can tell, I cannot see this. But this is what I see, is the text, your discussion of the result itself. Okay, so treat this as a report. You have a client. I am your client. I give you the homework problem. Solve it for me. Okay, give me a report. You give me a Jupyter Notebook without the discussion. Okay. Formatting should be clean and clear. This is up to you. I'll give you some pointers when we talk a little bit about graphs and descriptive statistics. For making beautiful plots. You will spend a lot of time doing research, but most of solving problems. But as you will see in life, you'll spend probably 80% of your time building your results, building plots, creating tables, and those have to be beautiful and presentable and readable and clear. Okay, so I will emphasize that as we learn a little bit about doing graphs and reporting things, dealing with data. So that was a little bit of a theme in numerical methods as well. This will be a little stronger in this semester. So if no discussion is included and we cannot interpret your result, so this applies to a programming question, for example. You're calculating the population standard deviation. You write the code for it. It prints out a result. And then you don't discuss it. You just move on to the next segment in your code. And if I see a number and have no idea what you're doing, if I cannot interpret the result, then I will not give you a point because I don't know what you're talking about. Now, if I can interpret the results, we will try our best. If we can interpret the result, remember there's 55 of you and only 3 of us, mostly 2 when grading homework assignments, right? So, and if everyone, if you want to spend an hour on each problem, 55, that's we will never be able to grade. Okay, so that's why these policies are in place. Now, if we can interpret your result, but no discussion and provided, you'll lose 50% on that question. It's very important that you are clear about what you're doing. You explain what you're doing. I don't want you to just copy paste from ChatGPT. Here's the code for a sample standard deviation and not understand what you're doing. I don't care if you get the code from GPT. I don't care. I do that. But I know what I'm doing. If you know what you're doing, all the power to you. Okay. This is an example of a homework report. This was done in Jupyter Notebook. You can replicate it in a Word document or in in a Google Doc, right? So, headings, homework 1, your name, your unit, problem 1, solution, etc. So just be clear and clean. Again, I'm not going to be prescriptive. Okay, you have the liberty to present your artistic way of reporting, doing your reports. That's up to you, but be clear. Okay, follow a simple hierarchy of headings, etc. Now, here's the partial credit policy for homework assignments. If the method is correct and no errors, you get 100%. If the method is correct but contains an arithmetic or a minor programming error, you lose 20% per error. Okay. So like on an exam, if you have an arithmetic error, you'll probably lose like a quarter of a point or 1 point out of 20, right? It's not a big deal on a timed exam. But on a homework assignment, you have all the time in the world. Okay, so there's no reason for you to make an arithmetic error because you can check your work, you have all the time, you can relax and do it. Okay? If the solution contains a minor theoretical error, you lose 40% per error. So, like for example, if you're doing the sample-based standard deviation versus the population-based standard deviation, there's a difference in the denominator, n versus n minus 1. That's a theoretical problem. If you make that mistake, then you lose 40% per error. And then if no discussion is included, we cannot interpret the result. As before, no points will be given. And if we interpret the result, we'll try our best again. So bottom line is like this. We'll do the first couple of homeworks together. Together in the sense that we'll do the first 2 homework assignments. We're going to be a little bit more relaxed and lenient in this policy, but give you feedback. Tell you, okay, don't do this next time. You will lose points on this and that. And then you'll be, okay, you'll get it. You'll know how we will be grading things, okay? We will have regular quizzes covering material discussed in previous lectures. Apparently, so last semester, there were no quizzes, but then after exam 1, I was like, okay, no, we're going to do quizzes because I want to make sure everybody is doing essay questions correctly. But the feedback at the end of the semester was pretty brutal. Like, you cannot start quizzes in the middle of the semester. I was like, okay, I'm going to make sure it's better logically to tell you we're going to have regular quizzes and then say no quizzes, and then suddenly have quizzes. So we're going to have quizzes, not every week, but plan that we're going to have a quiz every week that will cover most recent lecture material. Okay, maybe every lecture. So we'll have weekly quizzes, depending. Sometimes material is intense, we have to do 2 quizzes. Sometimes material is slow, we'll do 1 quiz or no quiz at all. Okay. No cell phones, no chatting. Please just focus with me. If there's something urgent, just step out, raise your hand, just sneak out, take your phone call, or I don't know, but I'd love you to just be focused on me, right? I know it's an hour and 20 minutes, and we're gonna integrate more breaks, hopefully this year, if the material allows it. So no cell phone, don't be distracted with chat. It's distracting to you, it's distracting to me, distracting to everyone around you. If you are sick, not feeling well, especially if you're like coughing or sneezing, stay home, let me know. I'll work with you, make sure that you get the updates, etc. Once you're feeling better, come back. And yeah, keep up with the class. All right, for exams, we will have 2 exams. And so, man, syllabi these years, it's like the iTunes user agreement. Like one time I tried, there was one professor at, I think, Duke who printed the iTunes user agreement back in the day. It was like, he printed it and taped all the papers together. He covered like a 5-story building just with that user agreement. Nobody reads that, right? Same thing with the syllabus. I have a long syllabus that's 15, 17 pages long. So I'm trying to summarize this here. You're welcome to load it up in ChatGPT and then ask GPT to summarize it for you. But essentially, we have 2 exams and a final. Exams might be of the handwritten type or entirely online. So last year, what I've been doing in the previous years is the midterms, exam 1 and 2, are entirely online on Canvas. And an online exam will consist of a lot of essay and low stakes questions. Like simple question, what's the difference between the standard error and the standard deviation? Or like explain why in the population sample standard deviation, we use n minus 1 and then n in the denominator and n minus 1 for the sample. very quick, short questions, okay, low stakes, a lot of them, 20, 25 low stakes questions. No partial credit on those. You either, because it's just one question with one answer, you either get it right or wrong. So usually exam 1 and exam 2 will be of that type. You'll come here with your laptop, you log into Canvas, and you see the questions, you go through them, you get one attempt. Usually most students finish within 30 minutes, and then you're done for the day. The final exam is generally a handwritten type exam. We'll see this year if it will fit within statistics. If it's of the handwritten type, then you will get a lot of partial credit every step of the way. If you make an arithmetic error, well, that may be 1% of the point, and then follow through as if it's the right answer, and so on. So there's more generous partial credit for handwritten exams. Okay, so that's discussed already. This is the tentative grading scale. Again, I'm sorry that this is kind of not showing up here. So this is the tentative grading scale. It will change. We'll see. I don't have the quizzes over here. Actually, this slide did not update from Google, so let me fix this. So we'll put quizzes here at 5%. Quizzes, so assignments 35%, quizzes and surveys, feedback on course material, etc. They will all count for 5%. 2 midterm exams, 17.5% each, and a final for 25%. Okay, trying to balance work at home and timed exams. Okay, I'm gonna skip this. So my slides apparently didn't update in Google. Okay. So this course is about statistics and not programming. But to do serious statistics, you need good software tools and programming skills. Brush up on your programming skills now. If you've done numerical methods with me, you've done Python, so you're kind of ready to run. If you haven't, you're welcome to look at some of my lectures on YouTube on numerical methods. There's a lot of kind of Python examples, but this will be different. We will be using Python very, very differently this year. And in the end, we're going to be touching on what's called Pandas, which is a library for dealing with big data. Hopefully, we'll get there. Start your homework early. I know none of you does that, but try. I have to say it. Start your homework early, because things will happen. By the deadline, things will happen. And if you email me, you're like, I'm running late, I'm going to tell you, then take the drop or the daily penalty. So you should start early, do the best you can, however many problems you can solve. Maybe you can solve them all, and then just be done with it, because you have no idea what's going to happen, and things will happen. Always there's something that's going to happen. Review class notes prior to the lecture, and try to review them after class. Again, sometimes it feels like a big ask, especially with your other courses. You see, every teacher thinks that this is the only course you're taking, right? So we all think that. So your other courses, your other teachers think you're only taking their courses as well. So we have control over all your time. You're dedicated 40 hours a week for this course. But the reality is you're not. So I understand that. But try to optimize your time. You're riding the bus. You're in an Uber. Open up Professor Saad Explains and listen, to the lecture, okay? And try to kind of keep up with the material. Rework the examples we did in class before homework. And again, if you're stuck, come talk to us, Ariana, Zach, or me. We're very responsive on Canvas in person. If I'm not on campus, I will do a Zoom meeting with you. Sometimes I've done Zoom meetings while I'm driving in my car, picking up the kids. I'm like on Zoom with it doesn't matter, okay? I'm not gonna do Zooms at midnight, so if I get a message from you like at 11:30 p.m., probably not gonna respond. I'll be doing something else, but I'll have to respond the next day. Okay. All right. Homework thoughts. Getting the answer is not the goal. So this is lifted out from. I put this slide in all my lectures. I don't want you to be a one-chord wonder. Essentially, oh yeah, I got the answer, but I have no idea how I got it. I'd rather you get the wrong answer, but understand the process, That's more important, the ability to be a critical thinker and recognize sometimes, like, this answer doesn't make sense. I remember an anecdote I had in my heat transfer. So I come from mechanical engineering background. Heat transfer is a little bit different, taught in mechanical than chemical. We do a lot more radiation heat transfer in the heat transfer course. And I remember having this, it was the second midterm, and we had radiation on it. And I had like an insane headache that day. I don't know what was going on. It was so bad. And it just blocks your mind, right? And I'm working through the problem, and I had two spheres in space at 1,000 degrees each, and was asked to calculate the temperature in the middle. And I had like 17,000 degrees in my calculation. And I put a note, this doesn't make sense, because it's 1,000, where the heck do you get 17,000? I got full credit for that. Yeah, it turns out I had a problem with the Boltzmann constant, and the calculation was wrong. But the fact that I put this does not make sense, if I was working on a project, with a little bit more time, I would figure this out, right? Because it's a timed exam, I didn't have time to figure it out, but my teacher, whose son actually now is a PhD student in mechanical engineering doing heat transfer. I recruited him. Anyway, the world is so funny. It's just such a small world. Anyway, so I want you to be like that. Okay, and that's a good thing to be in. Okay, getting the answer is not the goal, but thinking about how you got the answer and the process of figuring out whether this answer makes sense or not is more important. Again, I don't care about your writing code. The goal is to use code to do analysis. That's what your role is as a chemical engineer, as an engineer. Presenting your results is often as important as the results themselves. So I mentioned this a minute ago. You're going to spend a lot of time doing beautiful reports, so your plots need to be, imagine you spend hours and months working on a project, and then you put a crappy report with like illegible fonts and 1,000 tick labels. Nobody's going to understand what you did, right? That would be so sad. Instead, you want to invest some time in having good vision on how to present data, and we'll try to work some of that here in the course, but it's a journey. Hopefully by the end of your degree here, you come out, you can produce nice, good-looking plots that represent actual data. Okay, so what are we doing now? Excel, Python, R, MATLAB. We're going to use the tool that does the job best and most efficiently. If someone talks to me, they might think I'm a die-hard Python. It's like I'm the one who created the Python programming language. The reality is not. I don't care, Python, MATLAB, C, or C++. It doesn't matter. As long as you use the right tool for the right job, that's what's more important to me. Because all of these tools, they come and go. In the next 5 years, Python is not going to be a thing. There's going to be something else that's going to replace it. But you are going to stay. Your mind, your analysis, and your thought process is going to stay here. But the programming languages are going to come and go. What matters to me, though, is getting the job done in an effective way. So, for example, try to do a pie chart in Python. I've never done a single pie chart in Python. And as I was preparing the lecture for Thursday or next Tuesday, good grief, I had to write like 20 lines of code just to do a pie chart, and I couldn't customize it. But I went to Google Docs, I put the data, select pie chart, bam, there you go. So why not do it in Google Docs or Google Sheets or Keynote or PowerPoint? I don't care. So we're going to use the most efficient tool to do the job. And you will see initially, early on, when we are within what we call descriptive statistics, where we're taking data, we're calculating the mean, a standard deviation, we're doing a plot, a histogram. Almost exclusively, we will be using either Excel or Google Sheets. These are just easy. There's no point in obfuscating and getting lost in the programming, like just figuring out the bin sizes and the distances between them in Python. It's a nightmare. I don't want to waste my time trying to explain that for loop, how you figure that out, and then waste all our time, not have time to analyze the graph. I'd rather have time to analyze the graph that we're working with. We have a tool that does it. It's called Excel, called Google Sheets. I don't care. We'll use that. So you'll see initially the first few assignments, like make a plot in whatever tool you like, Excel or Google Docs, and then put it in your report and explain the result. That's what's more important, okay? So that's the strategy this year. Obviously, I have my eyes on data science, and I promised you that last year. And as we change the curriculum in chemical engineering, we have numerical methods before statistics with our eyes on data science. The objective is to get to a point where we are working with very big data. But you need to understand statistics before you make mistakes with data. So you can tell a lot of lies with statistics. You can twist the statistics to, there's a saying, says if you torture the data just enough, it will give you the answer you want. And so you can twist the data in any way you can, and you can present it in just weird ways and tell whatever agenda you have, okay? So we have to be very careful about that. Okay, so what you need to do after this class, review the syllabus, understand the class policies, the homework, the grading, etc. Get this over with and know where to get that information later if you forget something. Install Python. If you already have it installed, great. Make sure you have access to Google Docs, Google Sheets, or Microsoft Word, Excel. Subscribe to my YouTube channel. Make sure you can log into Canvas. Make sure you can receive Canvas announcement and emails. So there's a setting in the settings page. You should enable alerts for announcements or any email communication I send you. So you get an alert that I sent something. It's important. You got to read it. Find out where the help sessions are. So most of you already know where that is. And add the dates to your calendar so you can block some time to go to these help sessions, and find out where my office is. Okay, let's see.
Back around 2002, Target came to a statistician with a question, in which the answer could potentially make the company millions of dollars. They asked, using only computers, can you determine which customers are pregnant, even if they don't want us to know? And from then on, statistician Andrew Poole was in search of an algorithm to do just that. What he did was analyze the shopping patterns of expectant mothers and notice some common behaviors, like an increase in lotion purchases, loading up on vitamins, and more stuff that I know nothing about. And he uses information to not only determine which customers were likely pregnant, but what their expected due date was. And after developing his mathematical model, the statistician had a list of hundreds of thousands of women who were likely pregnant, along with their expected due date and what trimester they were. And from then on, Target could send coupons at just the right time over the next several months,
This kind of stuff.
even after the baby was born. Now, although Target was cautious about following secrecy laws, it still might turn women away if all of a sudden they started getting coupons for like cribs and diapers and other related items when they didn't in fact tell the company that they were pregnant. So what Target did was just sprinkle these items in along with some other unrelated products when coupons arrived so it would seem more natural. But about a year after creating this algorithm, something happened though, and this is where it gets interesting. One day, a man walked into a Minnesota Target demanding to see a manager who was very angry. And apparently what had been going on was Target was sending coupons for things like diapers and cribs and other related items to this guy's high school daughter. And he was very upset about it. He was saying things like, are you guys trying to encourage her to get pregnant? And the manager didn't really know what was going on. He, of course, apologized. And a few days later, the manager called the dad back to apologize again. But this time, the dad wasn't so much angry, but a little more embarrassed. I think you guys know where this is going. On the phone, the dad said, I in fact owe you an apology. There's been some things going on around here that I haven't been fully aware of, and in fact, my daughter is pregnant and due in August. So yes, this statistical algorithm figured out that this girl was pregnant before her dad even knew about it. That right there is the power of statistics. And
so that's what we will be learning. okay? Not to predict like, pregnant people and stuff, but, like this is the power of this. Analyzing data, creating a model just from the data, And numerical methods, what we did, or in heat transfer, in mass transfer, in kinetics, all the courses you're going to be taking soon, you're not starting with data. You're starting with a physical law, a conservation law, developing a formula, an equation, solving the equation to generate data. Statistics is the other way around. Imagine you were in a world where there's no differential equations, no calculus, none of that, just data. How do you make sense of the world? You use statistics. That's why AI is so powerful. It's not relying on models. It's just taking sheer data, because the data embeds what is happening in reality, and developing models from the data. These models could be just simple formulas like a straight line or a parabola, but it does the job. And this is how Target was able to target people like that. And so this is incredible. Netflix uses algorithms like this to figure out what you are more likely to like, what kind of movie suggestions. They have these really fancy statistical algorithms. So hopefully we'll learn some of these things. You will notice, though, that most sensational statistics story don't necessarily have to do directly with engineering or product design, right? They have to do with epidemiology, with people, with humans. So we're going to try to balance this. Some examples from medical industry specifically, like how if a drug is effective, if a medical test is effective, etc. Some of you who are doing biomedical emphasis, that will be very interesting. And so we'll also cover some specific engineering applications, like you're doing a batch of semiconductors. What is the likelihood that you're going to have a failure and whatnot? Asking all of these questions, blending engineering and other applications of statistics together. There's this really great statement by Charles Whelan. It's this really cool book called Naked Statistics. It's a fun read. You can it's not a technical book. It's more of a analysis book. Just thinking about statistics. He has this great statement. It's so easy to lie with statistics, but you cannot tell the truth without them. So that is so powerful, and that is a testimony of how you can twist any statistic to tell whatever agenda, whatever story you want. Now, in that video that I showed you, I'll put the link on Canvas. He goes through a lot of other examples when he shows how people can mess with the data to present a different agenda, or like doing, bar graphs, how sometimes these news channels, they could bias opinion by taking out the scale on the y-axis, not starting from 0, starting from 30 and showing, voter interest change from going, from 30% to 35%, but the bar would look like as if there was a 200% increase just because they removed the scale at the bottom. So tricks like that, you can tell a lot of lies with statistics, and that's what we want to be aware of. Okay? At the end of this chapter, my goal is that you'll be able to explain the statistical investigative process in general, define population sample and other statistical terms. There's going to be a lot of definitions in the first few lectures. So, flashcards, and I can even hardly keep track of all of those. Define the difference between parameter and a statistic. Explain the difference between descriptive and inferential statistics. To me, that was a big aha moment personally, because if you're like me and you've only had a cursive understanding of statistics, statistics to you means find the mean, find the average, find the median, find the standard deviation, and that's it. That's hardly scratching the surface. That's only called descriptive statistics, where you have information, you analyze it, and just report it. The power of statistics comes from inferential statistics, and that's where you build a model of life, of reality, just from the data. Okay? So we'll learn the differences between the two, explain random sampling, explain different types of samples, what kind of samples we can build when we're doing studies, explain the two types of statistical studies. There's two types we'll be dealing with: observational and experimental statistical studies. Explain the different types of observational studies. You've always heard like a longitudinal study, or a case study, or a meta-analysis, or a cross-sectional study. We'll learn what those mean. define and explain experimental studies and how to conduct them, and finally learn how to critique a study. I know this is chapter 1, but there's a lot you can do just by looking at the big picture and kind of starting to think statistically. The way, as I was building the course, I know two things when studying statistics. There's two big pieces of statistics: descriptive statistics and inferential statistics, or statistical inference or inference. So from here onward, if I say inference, I mean statistical inference. If I say inferential statistics, they're synonymous with each other. Descriptive statistics and inferential statistics. You're probably more familiar with descriptive statistics. Those are essentially, they focus on summarizing a set of data that you have, finding the average value, finding where half of the population lies, where the other half lies, finding the quartiles, if you're like 25th percentile or 90th percentile. These simple numbers, they're just descriptive statistics. You have data, you're describing the data, and you're not making any major inferences about the data. You're just summarizing it and reporting it. This is usually very helpful when doing like census and gathering your exam scores. For example, I tell you the average was this much, the standard deviation was that much, the high score was that, the low score. Those are just descriptive statistics. Descriptive statistics also includes plots and visualizations, and you're only focusing on the sample that you took. So you cannot draw conclusions about the entire population. So how many of you like coffee? Let's say, just raise of hands. Okay, so I'd say maybe 60% of you like coffee. I cannot say that 60% of the University of Utah likes coffee. I can only say that 60% of this class likes coffee. Now the question of how many at the University of Utah like coffee based on this result, that becomes inferential statistics. We'd have to collect more data to make an inference about the University of Utah entirely. But as far as descriptive statistics are concerned, all I can say here is 60% of this class likes coffee. That's it, period. Descriptive, I can make a plot with 1 point on it, and that's it, we're done. Okay? There's no uncertainty involved in descriptive statistics. I cannot say that, if I randomly pick a student from this class, how likely are they to like coffee? That's not in descriptive statistics. That question is for inferential statistics, because you need probability in there. Okay? So an example is reporting test scores of the students in a class. Include average, standard deviation, histogram, and we'll learn about standard deviation together in the coming lectures, okay? But you've probably heard of these words. So that's what descriptive statistics are. Inferential statistics, on the other hand, they make predictions or generalizations about a population. So obviously, if I want to understand, so the University of Utah has 33,000 there's employees and students. The population of the University of Utah has this many people. And if I were to ask the question, how many people like coffee at the University of Utah, I cannot send a survey to 33,000 people. First, they're not all going to respond, actually, right? So I have to figure out a way to do a sample or a subset of this population, maybe 300 people, okay, and ask them the question if they like coffee, and figure out how to choose those people. So I cannot choose people only from chemical engineering. I probably need to choose from lower campus, from upper campus, from business, from law, etc., right? So I have to figure out a way to choose different people from different groups, different degrees, different ages, etc., different genders, and so on, to make sure I get a nice idea, a nice representation of the population, and then ask them the question, and then figure out a way to make an inference about the University of Utah. That's inferential statistics. Now, so you're going from the small sample, the class, or the small number of people you picked, somehow coming up with a smart idea to make an inference about the total population. Okay? Now, this includes uncertainty and error, because then you can say, well, what's the likelihood of a certain, so the answer in this case would be, if I randomly pick someone from the University of Utah, what's their likelihood that they're going to like coffee? That would be the result of an inferential statistical analysis. Okay? Now, here's an example. A pharmaceutical company conducts this clinical trial on 200 patients to test a new drug for lowering blood pressure. Again, examples from the medical industry are great because we can only study them with statistics because we don't have mathematical models like in engineering. Using inferential statistics, they analyze the sample data and determine whether the drug is more effective than the current medication, and through what we call hypothesis testing, you learn about all of that. They conclude with 95% confidence, what the heck that means, that the drug does lower the blood pressure, and they calculate what's called the p-value and the likelihood that the effect is not due to chance, that it actually does does reduce blood pressure. So that's the power of inferential statistics. Nothing, no model, no differential equations, just purely from observational data. Okay? Now, the trick though, and that's always baffled me, like why do you need probability to do statistics? In every stats textbook, you'll see one chapter on plots and calculating the mean, and then like 5-7 chapters on probability. Like, what the heck do I need probability to do statistics? How does probability affect the mean value? Like, it's just mind-blowing, right? Why do you need probability to affect the mean value? It turns out that we cannot get away from probability as much as you might hate it. You cannot go away from probability if you want to do inferential statistics. But first, let's ask the difference. Is there a relation between probability and statistics? What do you think? And what's the difference? What's the difference between a probability analysis and a statistical analysis? Sorry?
I want to say that probability is somewhat of a guess.
A guess at like a result. Yeah. Okay, so let's take a die. If the die is fair, right? So, or a coin. If it's a fair coin, you have 50-50 chance of getting heads or tail, right? So probability would start with a known situation, with a known configuration. I have a fair coin or a fair die, and the probability in the fair die is 1/6, right? So you start from the system and you make a prediction using probability. With statistics, it's the other way around. I come to you and I say, I have this coin and I flipped it 1,000 times. Okay, 52% of the time I got heads and 48% I got tail. Is this a fair coin? Starting with the data and making the conclusion about the reality of the coin or the die, etc. They're connected, but they serve different purposes. So with probability, you know the physical law or the process. In this case, you know what we're going to call the hypothesis eventually, that the die is fair or the coin is fair. It's not biased. It's always going to give me the same result. You start with that statement and you make a prediction. Okay? You make a simulation, you make a prediction. The other way is statistics. You're starting with outcomes, with observations. You've seen a result. What can you say about the system? What can you tell me? Okay, this casino is, for example, producing winners all the time. What can you tell me about the machines in this casino? Versus the question, this machine has a probability of success of 1/100. How many people are likely to win, right? So two different, it's two sides of the same coin. Okay? They are connected to each other, but each one serves a different purpose. So the key question in probability that probability is trying to answer is, given the law, what outcomes can we expect from that law? The law is, again, a fair coin or a fair die or a biased coin, biased die, etc. Whatever it is, you know the condition of the system, you make a prediction. With statistics, it's the other way around. You don't know the condition of the system, but you know the results. What can you say about the condition of the system? Given the data, what can we infer about the law? So we're going sideways. Okay. Think of probability as starting. This is another example. Like you bake some cookies. You have the recipe to bake cookies, and these cookies I love orange scone cookies. Like you know, if I will forget everything and just eat like an orange scone cookie, okay? And so you get a recipe and you expect that these cookies are gonna have a flavor of orange, they're gonna be sweet and delicious and crunchy, etc. You know the outcome. That's probability, okay? Most of these cookies are gonna look the same, they're gonna taste the same, etc. With inferential statistics, you take a batch of cookies and you're like, what the heck did they use to make these cookies? Let me eat 50 cookies to figure out, you know, oh, there's orange, okay, I need another one. There's sugar, they must have put this and that. And then you start figuring out what the recipe is, okay? That's statistics. But still, I haven't answered the question. You cannot do inference without probability. So starting from here to here, we can do probability. But going from data to the physical law, you still need probability. That question always baffled me. But it turns out you need probability because it helps you quantify how correct or how wrong you are when you're going back from data to the law. Remember, hundreds of laws could explain the same data. Like if I pick a point in the plane, in the xy plane, could you tell me whether this point belongs to a parabola or sine function, cosine function, exponential? There's thousands of functions that will pass through that point, right? How do you determine which function is the correct function or the most likely function to pass through that point? You need some information on probability. You need an assumption on probability. So probability, you need probability to tell your statistical analysis how wrong or how correct you are. Let me give you an example. Here, I know it's baffling, but it clicked with me the other day, and I hope it will click with you as we learn throughout the course. And we will need probability. So we're going to do descriptive statistics, then take a detour, go through probability and counting cards and all that stuff, and then come back to statistics. But we need that detour because we need to learn some fundamental principles on probability. Here's an example. You flip a coin 1,000 times, and you observe 600 heads. And then you want to determine whether the coin is fair. Okay? So that's your thinking, okay, that's my law. Is the coin fair? That's the question. So I'm starting with observations, and I want to be able to determine if the coin is fair. Now, if the coin is fair, the probability of heads is 50%, probability of tail is 50%. And I have 1,000 trials, but I got 600 heads. That's like 60% of the results are heads, but could this just be due to randomness? Maybe I need 10,000 trials, right? Could this be due just to simple randomness? So if the coin is fair, you'd expect 500 heads with some variation, maybe 550 heads because you're only doing 1,000 trials. I don't know. How do you know? How do you know? This is where probability comes in, okay? This is where probability comes in. Using probability, you will calculate the likelihood of getting 600 heads with a fair coin. So you take your hypothesis, which said I have a fair coin, and I should expect 500. But what is the chance of getting 600? That's where you need probability. You started with the data, 600 heads. What's the likelihood of getting 600 heads? Turns out you have to use you can't just use the 50-50. You have to use what's called a binomial distribution. The binomial distribution describes events that have only two results, success or failure. We will learn about that. This is where probability comes in. Turns out that the probability of a fair coin getting 600 heads is 0.0000, it's 0%. So the coin is most likely not fair. Okay? That's a very simple example of statistical inference, but that's how we will use data, statistics. We need a probability step in there. What is the chance that our result is wrong or correct? And this is where the mystery lies and where your intuition comes in, is knowing what probability describes the system you're looking at, with epidemiology, with medical systems, with drugs, etc. What probability method you use to try to analyze the system. We're going to spend a lot of time just learning about those binomial distributions, Poisson distributions, bell curves, etc., to try to describe these systems, okay? And then finally, you make the inference. So this is just a very simple example of that. And the most critical piece in inferential statistics is figuring out the probability distribution. So when we learn about probability, we'll do some simple probability, some counting, etc. But then we'll spend a lot of time on looking at all the different distributions and what they mean. Okay? So on Thursday, we'll start with some definitions. Welcome to spring 2025, to this class. Looking forward to having a fun, good semester with all of you. Thank you so much. Okay, have a good day.